Welcome to the AWS Fundamentals series on Coursera. I'm Alan Goldberg, Technical Program Manager in AWS Training and Certification. In this class, Going Cloud Native, we will focus on some key technology areas and services. Specifically, for compute, we will look at Amazon Elastic Compute Cloud and Amazon Lightsail. We will discuss virtual private cloud and other networking technologies. For storage, we'll see how to use Amazon S3, Elastic Block Storage, and Elastic File Service. We'll also explore Amazon DynamoDB and Amazon Relational Database Service. How do you monitor and scale your application environment? We'll use Amazon CloudWatch and autoscaling. Finally, we'll examine how you can secure your environment in AWS and manage cost. We'll do all of this through a cloud-based application that we'll build over the course of the class. The app stores images and information about fictional employees in a company. There's no coding requirement for this course. All of the examples and demonstrations will use the AWS Management Console. I will be joined in this class by two of my AWS training and certification colleagues, Blaine Sundred and Morgan Willis. In the next segment, we'll introduce ourselves and then move on to course content. Blaine will begin with an overview of AWS, where he'll talk about AWS regions and availability zones and why they matter. Morgan will then walk you through our application, introduce you to compute services, and dive deeper into Amazon Elastic Compute Cloud, or EC2. Blaine will finish up the first module with a look at Amazon Lightsail, a service that allows you to quickly and easily spin up entire web-based application servers with just a few clicks. Along the way, there will be quizzes and links to resources to help make sure you are on the right track. So again, welcome to Going Cloud Native on AWS. And as we say at Amazon, work hard, have fun, make history.
Hi, I'm Blaine Sundred, Senior Technical Trainer for AWS.
I'm Morgan Willis. I'm a Senior Technical Trainer here with Amazon Web Services.
I'm Alan Goldberg. I'm a Technical Program Manager at AWS.
I've been in technology for about a decade now. I started off, like a lot of other people did, just as help desk.
I'm a teacher. I've always been a teacher. I had no choice but to be a teacher. My mama was a teacher, my daddy was a teacher, my grandpa was a bartender. I mean, I was doomed to be a teacher.
I ended up in computer programming, where I was a Java developer for a number of years, and then I started teaching Java development.
My first job ever was as a swim instructor. And I got to teach people how to swim, and again, sort of thing. You know, when they get it, there's this sense of accomplishment that the students get, and it's really a lot of fun.
One of the things I really like about AWS is the way that we focus not just on the features. I mean, features are about the company. We are about the customer, and we want to know what problems the customer have. What do they need to solve?
Something that I love about working for Amazon Web Services is just that there's so much to learn. And our platform is so broad that really we can help a wide variety of customers.
You see the lights go on. You see when someone who didn't understand something, now they get it. Now they say, oh, how can I use this?
We're here to help customers with their real world problems, solving some amazing things. It's our customers that are what's really amazing out there in the technology world. We're just giving them a platform.
The thing about Amazon Web Services is that because we have so many different types of features available on our platform, we can help a wide variety of customers. So I get to help out all different types of people and push myself and continue to learn over time as well.
Welcome back, Blaine here. Today we want to talk about an introduction to AWS, to its services. But to do that, I really want us to look at the question, what is cloud? What is AWS? Now, there's many definitions out there, but the one that we're going to go with for this course is the idea of an on-demand, pay-as-you-go IT services that are delivered over the internet. Each one of those parts are important. The idea of an on-demand service, that you don't have to make any advanced contracts with us. You don't have to let us know what's needed. The moment you need services like storage and compute or networking, they're available immediately without any advanced contract, which goes the same as pay-as-you-go. that you don't have to have any prepaid tier. There's no minimum requirement needed to be part of AWS. Delivered over the internet means it's secure and available anywhere for you and your business. That's what cloud is. But a better question, why is cloud? Why does AWS exist in the first place? People might say, well, it's just a substitute for what you have on premises. And I disagree with that statement. Instead, a better answer to why AWS exists is to look at the idea of IT as a series of actions. And some of them are very important to your business, and some of them are common everywhere. Everybody needs compute. Everyone needs storage. Everyone needs identity management. AWS exists to eliminate those undifferentiated heavy lifting tasks that your IT department needs, that everyone's IT department needs. This means your business can spend time working on what is strategically unique to you rather than repetitive, common tasks that everyone has to do. So, what are the things that make up the AWS cloud? Well, there are some obvious things we've already talked about. This idea of compute, common areas where you can do all your calculations, storage of all different types, networking that allows you to have your own private network while at the same time allowing in exactly who you want to have be part of your application. But at AWS, we go so far beyond that, and there's many other things that are not so obvious at first blush. AWS has a high level of security with many security features written specially for your operations team. We have automation suites designed to deploy all of your applications, all of your databases, all of your environments automatically. We have database as a service, DevOps, which can be delivered soup to nuts right there as part of the services we offer. Media services, artificial intelligence, machine learning, ML, Internet of Things, IoT, services like game development, identity management, augmented reality, virtual reality, big data, analytics, and the list keeps going on. We have over 150 unique services at AWS, and that list continues to grow year after year. The pace of innovation at AWS is one of the important factors we bring, that we are constantly adding, constantly innovating on behalf of you, our customers. We even have a partner network designed to answer questions that may be specific to you and your vertical. The AWS Partner Network, APN, along with the AWS Marketplace, can provide on-demand solutions, pay-by-the-hour solutions that will allow your company to get exactly what it needs when it needs it. All right, next topic, let's look how AWS distributes our services globally. Welcome back. Blaine here. We want to talk about how AWS actually deploys our services regionally. So to start with that, we want to ask a question: what is a region? A region is a geographically self-contained area where all of the resources you need for your application, all the compute, all the storage are contained. It's going to be inside a single country boundary, bounded by a single set of laws, and they are right now located all around the world. You might find that we have a region located in London, for example, or maybe you've got one that's down in Sydney, Australia, or Montreal, or maybe down in Sao Paulo, Brazil, or Frankfurt, Germany. We have many regions all over the world. I'm not even going to give you the number because probably by the time you watch this video, the number will have changed again. Every region is designed to be self-contained, to have all the assets you need to run your application, which means right now the only question you have to ask is, which region is the right region for your business? It turns out there are 4 specific questions, 4 considerations that you need to ask when you decide which one of these many global regions is going to be the right one for you. The first question is pretty obvious, and it has to do with latency. Where are your customers located? If you've got customers, for example, that are living in Rio de Janeiro, where's my Rio graphic? There we go. If they live in Rio, it makes a lot of sense to run your application out of the São Paulo region, simply because speed of light is going to be a lot closer. Sure, you could run over in Frankfurt, but the distance around the globe to get to your customers is going to cause that extra bit of lag that is simply unavoidable. That's just a speed of light question. So if speed to your customer is your #1 priority, then certainly latency becomes my consideration. But there's some other things. Not every region is priced the same. Because each different country has their own set of tax laws, their own financial situations, you'll find the exact same services in different regions may have different costs. Now, you can find out exactly what these costs are at any time by simply going to aws.amazon.com and looking to the different regions where we'll explicitly tell you service by service exactly what your projected costs will be. You might find there's a significant difference region to region. For example, our São Paulo region is a wonderful place if you're dealing with a latency issue for your Rio customers. But simply due to local tax laws, it also happens to be a little more expensive than many of our other regions. So if budget is one of your strong considerations, you might look to one of our North America regions, even though the latency may be more. But legal restrictions may change the entire conversation altogether. You might have specific United States HIPAA requirements, or you might have European GDPR requirements. Or let's say you actually have a business that's running in Germany, in which case you might be required by law, based on the type of load you're running, that you must run in the Frankfurt data center. And while you'll have great latency because your customer's in Germany anyway, that this compliance outweighs any other consideration because of legal restrictions. So make sure you understand if the country you operate in has requirements that may dictate everything right away. And finally, service availability. We try to roll every feature out to every region, but sometimes a brand new feature gets released. For example, at reInvent, we often release dozens of brand new services. And those may take a few months to actually get into every region around the globe. So if you want to try one of the brand new services, make sure you know which region they're operating in. It might be operating over in Dublin or perhaps in the Northern Virginia region. You'll find the right location for you. Eventually, they'll probably be running in every region, but if it's new and you want to try it, check the region out first. So that's why you choose one region over another. But what makes up a region itself? Well, to do that, let's go ahead and dive into what a region's made of. So as we look at what is a region, we want to ask, what is a region actually made of? What are the pieces that together comprise this geographically separate area? At AWS, a region is a collection of availability zones. Now you can think of an availability zone as if it was a standalone data center. Now the truth is, at AWS, an availability zone might actually be more than one data center, but we don't make a big deal about that. For us, this single object, while it might be 2 or 3 buildings and might be spread across a parking lot, we call this one availability zone because it's logically treated as that. Inside a region, we always have at least 2 availability zones separated by miles of distance, tens of miles of distance. And we do this specifically to protect you against what? Your lizard friend. Yes, your favorite lizard and mine can be, unfortunately, a cause of problems for your application. Because when your lizard friend comes to be angry in a particular area, your lizard friend is going to find your set of data centers, an availability zone perhaps, and by dancing around could cause enough trouble that you could lose connectivity to everything in that availability zone. At AWS, we don't want you to have to worry about that. So a region is made up of multiple availability zones, and you don't have to worry about the distance between them because AWS connects those availability zones with a proprietary high-speed fiber network, multiple lines between every availability zone, so you can treat it as a single area. But you run your application simultaneously across all the availability zones. You might have application servers that run in both AZs. And you might have a database where you've got your master in one availability zone that connects to a standby in a different availability zone. The idea is it doesn't matter what might happen to an availability zone, because maybe it's not your lizard friend this time, but there might be some other natural disaster, a hurricane, a tornado, an earthquake, that we don't want you to worry about. It doesn't matter if there's a temporary loss of connectivity to an availability zone because your application runs in both of them at the same time. This is how you can not only be effective, be scalable, but also highly available, all while running in a single region of your choice.
Hi everyone, Morgan here. Throughout this course, we're going to be building out a corporate directory application to show everybody how different AWS services can work together to build an application. If we look here, you can see our standard architecture. We're going to have traffic coming in through the internet to hit an elastic load balancer, or what we'll call an ELB. From there, the ELB will distribute traffic across our Amazon Elastic Compute Cloud, or EC2 instances. We also are going to be using Amazon Simple Storage Service, or S3, to store our images for our application. And we'll be using two different types of databases behind the scenes. We'll have Amazon DynamoDB or Amazon Relational Database Service, or RDS. Let's take a look at what our application is going to look like when everything's all said and done. Here's our application. You can see we already have data populated in the application. We have Blaine and Alan added as contacts in our corporate directory. So let's go ahead and add another one. I'm going to add myself. So I'm going to just click on the Add button here and give myself a name. My name is Morgan Willis. Location is USA, and job title is Tech Trainer. I'm going to give myself some attributes like Mac user, frequent flyer, and paperclip aficionado. I'll go ahead and save this. And I realized I didn't give myself an image, but the lucky thing is that our application allows us to edit records as well. I'm going to select my entry, click Edit, and then I will choose an image. Select my image, open it, and save. So now we've been redirected back to our home screen here, and you can see we've added me into the application. We also have the ability to delete. So this is what our application is going to look like when everything's all said and done. I've mentioned a few services like Elastic Load Balancing, EC2 instances, and S3. Don't worry too much about that for now. We're going to cover these in detail throughout the rest of the course. Hi everyone. Let's hop in and talk a little bit about computing with AWS. In an earlier module, we introduced the concept of compute as being one of the core services offered by AWS. In the upcoming modules, we're going to dive into a few different compute services, such as Amazon Elastic Compute, or EC2, and Amazon Lightsail. Before we get too much further, let's define what we really mean by compute services. In order to power your business, you need some sort of compute capacity available to you to run applications. In a traditional environment, you would first need to estimate how much compute capacity you're going to need, buy the necessary hardware to support that capacity, and stand up the computers or servers to run your application on. Once you deploy your application to those servers, you must maintain that server from the physical maintenance perspective, as well as from a software perspective. In contrast, when you're building cloud-native applications, you can shift to using a compute-as-a-service model, which allows you to provision and consume raw compute or server capacity over the internet with pay-as-you-go pricing. This would take away the burden of standing up and maintaining those physical servers, while still allowing you to have the control over what type of hardware you need to run and the software that runs on top of it. In addition to building out and maintaining compute infrastructure in a traditional on-premise environment, what happens if your initial estimate for capacity was not enough or too much? If you under-provision resources, your users will feel the effects of a slow application or service. Latency leads to user dissatisfaction, which could impact your business. To remedy this, you would need to go out, purchase more servers, and follow the same process of installing, setting up, and maintaining those physical servers. On the flip side, if you over-provisioned, well, you're going to be paying for those idle resources and driving up costs unnecessarily. Wouldn't it be nice if you could just provision the capacity you need on demand? AWS compute services allow you to do just that. These compute services can easily eliminate the pain of under-provisioning or over-provisioning resources by offering flexible, scalable, and configurable compute resources in the cloud to meet your specific needs. AWS also offers managed compute options like Amazon Lightsail that allow you to use compute capacity without worrying about provisioning or managing the underlying hardware. In addition, we have other options that go beyond raw server capacity. We offer container services that allow you to use Docker through Elastic Container Service, or ECS, or Kubernetes through EKS. We also offer pure serverless solutions like AWS Lambda. With the flexibility of AWS compute services, you can run virtually any application in the cloud. In the next sections, we will discuss a few compute services specifically. Now that we have discussed at a high level what compute services AWS has to offer, let's talk about one in particular. Amazon Elastic Compute Cloud, or what we will call EC2 from here on out, is a compute service that allows you to provision virtual servers on demand. Each virtual server you provision is called an EC2 instance. Just about anything you can do with a server in a traditional sense, you can do with an EC2 instance. They would have to purchase those machines, wait for the delivery of those machines, install them, lay down the networking and storage systems for those servers, and then maintain that infrastructure to have any of their applications running. EC2 allows companies to provision servers on demand without acquiring massive capital to build out their compute infrastructure. In other words, if you need a server, you can just launch one, and it's available to you in minutes. EC2 instances are flexible, and you configure them to meet your needs. You can commission one or many instances easily, and at the end of a billing cycle, you only pay for what you use. When you no longer need an instance, terminate or stop that instance, and you will stop incurring charges. The configurability of EC2 extends to the platform that you want to run. AWS supports a range of operating systems, including Linux, Ubuntu, Windows, and more. To select the operating system, you choose an Amazon machine image, or what we call an AMI. An AMI contains information about how you want your instance to be configured, including the operating system and possible applications to be installed on that instance. You can launch one or many instances from a single AMI, which would create multiple instances that all share the same configuration. Beyond the operating system, you can also configure the instance type and size, which correspond to the amount of compute, memory, and networking capabilities available per instance. This allows you to control the underlying hardware and the capacity of that hardware with just a few clicks or lines of code. AWS offers many different types of EC2 instances. Different types of hardware are best fit for different situations. Each instance type is a grouping of hardware technology that are optimized for various use cases. The instance types you can choose from include compute optimized, memory optimized, storage optimized, and more. For example, the G instance type is optimized for graphics-intensive applications, which would work best for use cases such as 3D visualizations or video encoding. The great thing about this technology is that you are no longer locked into hardware decisions up front. If you choose an EC2 instance type and then later realize a different type would have been better suited for the application, you can easily change the underlying hardware. If you decide that you want to resize your EC2 instance, that isn't a problem in the cloud either. EC2 is a resizable resource with a few clicks in the console, or can be done programmatically through an API call. This enables you to embrace change over time. You can do these changes manually, but we would recommend that you automate these sorts of changes, which you can do with ease using some of our other services. So how does this impact your business? Virtual servers are not a new thing, but with the flexibility and low-cost nature of EC2 instances, the ease of provisioning servers allows for programmers and businesses to innovate more quickly. You can spin up servers for a short amount of time to run experiments and find optimal configurations for your applications. This ability to adapt to change and act on insights into your fleet of instances is very powerful in achieving a cost-effective and performant system. Next, let's launch and configure an EC2 instance to see how all of this works. Welcome back, Morgan here. We just got done talking about what an EC2 instance is, some of the different ways you can configure EC2 instances, and we defined all of those terms. What we're going to do now is we're going to launch an EC2 instance, and we're going to deploy our directory application to that EC2 instance. So we're going to hop in the console and configure one. We've already logged in, so the first thing we're going to do is click on the EC2 service console. So we're going to go ahead and click on EC2, which brings us to the EC2 dashboard. From this point, we can launch an EC2 instance pretty simply. I'm going to walk you through that process now. First thing to do is to click Launch Instance. This brings us to the screen where we can select an AMI. We've already defined what an AMI is. That's our Amazon Machine Image. This is what allows us to configure what operating system, web server, or other software that we have running on the machine. So we're just going to go ahead and select Amazon Linux 2, which is the first one. We'll click Select, and that brings us to the screen where we can choose an instance type. An instance type, again, is what is controlling the underlying hardware and the capacity that hardware can support. We're going to select a T2 Micro because it's free tier eligible, and we'll just click Next to configure the instance details for that instance. All right, at this point, we have to select a VPC to launch our instance into. We'll cover this later, so don't worry about it too much. We're just going to go ahead and select the app VPC. Similarly, we also need to determine what kind of subnet we're going to be launching into. We just need to make sure that we're in a public subnet, and again, we'll talk about that later. Scrolling down a bit, we also have to select a role. We're going to select the instance role for this. Roles are what allow one service in AWS to communicate with another service. Now we're going to scroll down to the Advanced Details section. If I click Advanced Details, it will expand and present me with a place where I can paste my user data. User data is what allows you to define what type of scripts will run once your EC2 instance has launched. I already have mine copied, so I'm just going to paste it here. This script is going to reach out to somewhere in AWS to get our source code, unzip it, and then run that application on our server. So now that we have our user data, I'm going to go ahead and click Next to add storage. We don't have to worry about this for now. We'll talk about it later. I'm just going to leave the defaults and skip through to tags. Tags are a feature that allow you to categorize your EC2 instances. Common tags would be things like name, where you can name your instance, or department, so you can figure out which department owns the instance. We're going to go ahead and add a tag here, and I'm just going to give it a name. So give it a name, and we're just going to name it Demo. At this point, we'll click Next to configure the security group. We are going to select an existing security group, and we can see here we have a web security group. We'll select that one. What this is letting us do is it's going to let us reach our instance over HTTP. We're deploying a web application to this EC2 instance, so we want to be able to reach it over the internet. That's all this is letting us do. So we're going to now review and launch our instance. We get a warning here. That's fine. We don't have to worry about it. We're just going to continue through it. All right, so let's review our instance before we launch it. We have a Linux machine that we're going to be launching. We determine that through our AMI. Our instance type is a T2 Micro. Again, that's our underlying hardware. We have a security group that will enable HTTP access. And if we scroll down, we can also see the tag that we defined as well. All right, so let's go ahead and click Launch and see what we got. Here we just have to acknowledge that we have a private key pair for this. We're not going to worry about this for now. We'll just go ahead and select Acknowledge and launch the instance. Now that we've launched our instance, it's going to take a few minutes to come up, but we can scroll down and click View Instances. Now that we're back at the EC2 dashboard, we can see that our instance state is running, but the status checks are initializing. We're going to wait for those status checks to pass before we go and look at our application. Now we can see our status checks have passed, our instance is up and running, and we can go and access that instance through its public IP address. So we're going to make some more space on the screen here. I'm going to expand this. We can scroll down and see there is extra information about our instance if you wanted to look at it. The only thing that I need is this public IP address. So I'm just going to copy this and open up a new tab so we can access our application. Make a new tab, paste that IP address in there, hit enter, and this is our corporate directory application. You can see right now it's empty. So to test our application, we're just going to add somebody to this directory and just see that data come back to us. So I'm going to go ahead and click Add. And I'm going to add Blaine into our directory. So for the name, we're just going to say Blaine Sundred. Location is going to be USA. Job title is going to be Lizard Keeper. And we're going to make him a Mac user and a paperclip aficionado. We're going to go ahead and also select an image. So I'm going to choose File and browse to Pictures, and we'll select our image of Blaine. Click Open and click Save. Now we've been redirected back to our home screen, and we can see that we've added Blaine successfully into our application. Now that we've been redirected to our home screen, let's recap what we just did. We decided to launch an EC2 instance, we selected an AMI, configured the instance type, gave it some user data, which reached out and deployed our application to this instance, and then it was up. We're able to add data to this application and then see it come back. So now that all that's done, I hope you get a chance to spin one up yourself, and we'll catch you in the next video.
You just heard Morgan talk about all the wide range of things that can be done on EC2 and compute at AWS. Some of you, though, you just want to simplify the whole process. You don't want to be a developer. You don't want to go through the process of spinning up an EC2 instance. You just want a solution to running your application. Well, AWS has a solution called Lightsail that has a number of pre-built options that you simply select, launch, and you're done. For example, you might just want a WordPress site. Lightsail has one already built for you. All you have to do is select it, and for a few dollars a month, all of the management is taken care of on AWS's side. So whether it's a WordPress site or perhaps an e-commerce site, in which case you might use our Magneto offering. We have offerings for Drupal and Joomla and Redmine and Plesk, a whole variety of different options. Or maybe you want a dev environment that your developers could work in, with a LAMP stack or a mean stack, or maybe a Docker environment. Maybe you want your own GitLab or just a programming environment like a Node.js or an Nginx server. The key part to Lightsail is AWS takes care of all the choices that now you don't have to make. Remember, the reason AWS exists is to help eliminate your undifferentiated heavy lifting. So AWS automatically provides a secure network, SSD storage, any load balancing you need. We take care of all the backups and compute, all these things that make up those pieces of your application now are just there for you. All you have to worry about is the content. You know what? Let's see how this plays out for real. We're here on the beach today to show you how simple AWS is when it comes to using Lightsail. All you have to do is log into your account. And right here on the home page, you're going to be able to go and build with Lightsail just by clicking on the Lightsail login. Now, the nice thing with Lightsail is it's designed to step you easily through the different pieces that you're going to need without any technical explanation. Why, yes, I would like to do this in English. So once you save that, then the engine here is going to step you through the pieces. Let's get started. The first thing that it's going to ask you is what type of application do you want to run on Lightsail? Now, you could run a WordPress application or maybe get into one of the other more complicated elements. For example, let's say you want to run a LAMP stack or run a Drupal server. These become easy choices. Once you make them, everything else happens without you needing to worry about the micro details. So let's go ahead and launch a WordPress server here. Once we've got that established, we then decide how big of an engine do you want to run? Do you want it to have a high volume, high velocity, or just a nice, simple starting one? And we'll even pick up the cost the first month free. Got to give it a name. So what are we calling this? Why, this is my corporate WordPress site. Let's make it. And at this point, you sit back, you enjoy the beach, nice palm tree by the way, and wait for it to launch. And in a matter of a minute or so, it'll be ready. Oh wait, it's already ready. That was it. We're set here, it's already running, and we can go ahead and click on that WordPress site. Now, by the way, if you want more information on how to actually use WordPress, there's a link right here to the Get Started guide so you can learn more about how you can be a site admin, but everything you need to go is all set. There's the IP address. Open up a new tab. And that's it. The user blog is all set. You got your Hello World post already ready to go. There's your admin login. It's that simple. Now, from here, you can take it wherever you want to go. Where I want to go, I want to sit here some more.
Welcome back. Alan here again. In the first module, we covered a lot of territory. We introduced AWS and discussed the various services available. Blaine explained regions, availability zones, or AZs. We then dove into compute services, looking at Amazon EC2 and Amazon Lightsail. Moving into this module, Blaine will show you how to configure an Amazon Virtual Private Cloud, or VPC. Next, Morgan and Blaine will elaborate on storage, diving into Amazon S3, Amazon Elastic Block Store, and Elastic File Service. Like in the last module, we'll have some resources associated with each of these topics, as well as quizzes to keep you on the right track. Let's get started with Module 2.
Welcome back. Blaine here. Today, we're going to start talking about networking on AWS and how the Virtual Private Cloud, or VPC, is used to isolate your application from the millions and hundreds of millions of other applications all running on AWS as well. We're going to do it by showing you here on the board, as well as do some live demonstrations in a little bit. But I want us to understand what it is we're about to see before we get into the technology itself. To understand VPC, we need to accept the fact that the point of VPC is to provide a frame, to provide a box that all of your application lives inside. And the idea is nothing comes in the box, nothing gets out of the box without your specific permission. And whether you're filtering by network protocol or port or IP address or by user or other information, you maintain complete control of all the assets inside your VPC. When you create a VPC, you also then divide the space inside the VPC into subnets. Now, in an on-premises world, subnets might be used to gather up servers or instances that need to talk quickly to each other. In the case of AWS, while you certainly could think of subnets the same way, from a functionality point of view, subnets are primarily used to determine access to gateways, to ingress-egress, as well as to isolate specific traffic that you don't want to talk to each other or do want to talk to each other. So in this case, we've gone ahead, we can create a VPC. we create a subnet, and then when the time comes, we'll go ahead and launch an EC2 instance inside this subnet. I think we're just about ready to build it up to this point. To do that, I need help from my friend Morgan. Are you ready, Morgan?
Yep, I'm ready.
You know, Morgan, this is an important lab, more than our other ones. I think we need to do this as a real lab. Are you ready for that?
Does it look like I'm ready for a lab?
All right, now we're ready to do the lab. What we're going to build out in this lab, we're going to start by building out the VPC, and then we're going to build out the subnet, and we're going to keep adding more things as we go. To build the VPC, you only have to declare two specific things: what region you're selecting, and remember we've already talked about the reasons why you might choose one region over another, and then the IP range for the private IPs of everything that's going to run inside this VPC. Now, we're not going to go deep into what CIDR blocks are or why you might choose one IP range over another. Those would be covered in different classes. But just in case you're interested, for this VPC, every private IP address in here, we're going to set to start with 10.10, and then we're going to wildcard the last two octets. Or in CIDR notation, we would call this 10.10.0.0/16. Once she makes the VPC, then Morgan's going to make the subnet. Now the subnet is a subset of the IP ranges for the VPC itself. And we're going to want more than just one subnet, so we're not going to use the full 10.10 and wildcard all of them. We're just going to wildcard the last octet. So she's going to identify this as 10.10.1 and then wildcard only the last octet, which in IP CIDR notation is a /24, meaning the first 24 bits are frozen. All right, Morgan, go ahead and build that out.
Got it. All right, so we're going to hop into the console here, and we're going to create one VPC with one subnet. So if we're looking at the console, what we're going to do is go to VPC, click on this, and this brings us to our VPC dashboard. At this point, we can launch the VPC wizard, and we want to create a VPC with a single public subnet. We'll go ahead and click select, and now we have to define our CIDR block, or what Blaine defined as 10.10.00/16. So we're just going to go ahead and change this to be 10.10.00/16. We also have to give our VPC a name. This VPC is going to be used for a directory application, so we're going to call this directory VPC. Next, we have to give our public subnet a CIDR range. We define that as 10.10.1.0/24. The next thing we have to do is select an availability zone. You'll notice that we already are in the Oregon region if you look up in the upper right-hand corner. So I'm going to go ahead and select US West 2A as my first availability zone. We'll leave the subnet name as public subnet and go ahead and just click Create VPC. We can now see that our VPC has been successfully created. Blaine, back to you.
Great. Now, we're just about ready to go ahead and launch the EC2 instance in there, but we've got one more thing we have to add to make all of this work. And that is, you've got a VPC, but remember, the VPC stops all traffic in and all traffic out. And if we're going to put a web server in there, well, that means nobody can talk to it. So we have to add a gateway. Now, the gateway is called the Internet Gateway, or the IGW, the Internet Gateway. She's going to create the Internet Gateway and attach it to the VPC, and then she'll create a route table and associate that with the subnet so that any communication that wants to talk to assets in this subnet can come in and out of that IGW. Go ahead.
All right, got it. So what we're going to do now is we're going to create an internet gateway, we're going to create a route table, And then we're going to associate that route table with our public subnet. Again, this is going to allow our public subnet to accept traffic from the internet. So if we look at the VPC dashboard again, the first thing we're going to do is create an internet gateway. Go to the left and select Internet Gateways. We already have some other things in here from previous projects. That's fine. We're going to go ahead and create a new one. So we're going to say Create Internet Gateway, and we're just going to give this a name. This is going to be our Directory Gateway. And then all we have to do is click Create. Now our Internet Gateway has been created. If we click Close, we'll come back to our main screen, and you can see we have a new gateway, Directory Gateway, and the state of it is detached. What we need to do is we need to attach this gateway to our directory VPC. So I'll select this, click Actions, and then click Attach to VPC. From here, we will select our directory VPC. We'll click Attach, and now our directory gateway is attached to our VPC. What we need to do next is create a route table that allows that internet traffic to be routed to our public subnet. So I'll go to the left and click Route Tables. From here, I will create a new route table. We'll give our route table a name, Public Route Table, and then we'll select our directory VPC, and then we'll click Create. All right, at this point, we can see our public route table has been created. We've selected it, and down below, we can see we have one route in here that allows local traffic. We need to edit this route table so we can allow public traffic from the internet. So I'm going to select Edit. I'm going to edit this route table, add another route, and this time I'm going to add a route for 0.0.0.0/0. This represents the traffic from the internet, and we will route that internet traffic to the directory gateway, which we created in our last step. From here, I'll click Save, and we're not done yet. We also have to associate this route table with our public subnet. So I'll click on Subnet Associations, and I will edit this, select our public subnet, and click Save. All right, simple enough. Now I've done everything manually here, but in a production environment, we would recommend that you do this programmatically. Blaine, what else do we got?
All right, we're good. So VPC we've got, subnet we've got, IGW we've got, and the IGW is now associated with this subnet. Now all we have to do is launch the EC2 instance, and we've seen that already. That's pretty simple. So Morgan, when you're ready, go ahead and create an EC2 instance in the subnet.
All right, you know, Blaine, in the amount of time that you were talking, I already built out an EC2 instance, and I've already showed you guys how to do this. So I'm just going to show you. I built out an EC2 instance. I'm going to click on Running Instances. We can see I already have it running. The status checks have passed. I'm just going to copy our public IP address and show you that we can get to our application. I've already populated our application with some data as well. All right, we're operational. Our EC2 instance is running. What else you got for me?
There, we've seen it. She can now connect to it by going through the IGW. It's launched. We know what's happening. We have now completed the foundations of networking on AWS. There's more we want to do with networking on AWS because we've already created one subnet, and it's associated with the public internet gateway. It's part of our VPC. But now we want to add the data plane. Now we want to add a database to it. But a database does not go, shouldn't go, in the same public access subnet where my web servers are, because I never want anyone from the outside, at least in my business case, to access a database directly. So we're going to make another subnet inside my VPC, but this subnet will not have access to the IGW. So this subnet is what we call a private subnet. And Morgan's going to create this and assign it the IP range of 10.10.2.0/24, but she's not going to assign IGW access to this. Go ahead.
All right, easy enough. What we're going to do is come in here and we will just select subnets. From here, we can create a brand new subnet, and we're going to make this one private instead of public. So I'll click Create Subnet, give it a name. We're just going to call this Private Subnet. We'll select the VPC, which is our directory VPC. And then we need to give this a CIDR block. We'll say 10, 10, 2, 0/24. Then select Create. And that's it. We have our subnet. Okay, let's keep going.
Now that the subnet's created, now we can go ahead and launch a database. We'll launch an RDS database. And then our application will be able to connect to the database because they live inside the same VPC, but nobody from the outside will be able to connect direct to that database. Go ahead.
Well, I've already created a database for us. Blaine's going to show you how to create and configure your database in a future module. So for now, if we take a look at our application here, we can see our data is coming directly from our database. So we already have it up and running. We can connect to it. We can connect to our app, but not the database directly through the internet. So Blaine, that's it, right? What else do we got?
Nice. We've got a functional application that goes and talks to the database. But wait, remember our lizard friend and the idea that I don't want to run in just one availability zone? I want to talk about high availability. So for that, we want to move beyond just one availability zone into a multi-AZ strategy.
Don't worry, I haven't forgotten about my lizard friend. So what we're going to do now is we're going to create 2 new subnets, one public and one private, in a separate availability zone. This is going to give us that high availability that we need. So first, we're going to create a new subnet. To do that, I'm going to click the Create Subnet button. And we're going to give this a name, Public Subnet 2. We're going to select the VPC, which is our directory VPC. And then for the availability zone, we have to select US West 2B since we first launched in 2A. Then we'll give this a CIDR block of 10, 10, 3, 0/24, and then click Create. We'll close that, and we'll also create our private subnet. So we'll click Create Subnet again, call this Private Subnet 2, assign it to the same directory VPC, assign that to the same US West 2B availability zone, and then we'll give this a CIDR range of 10, 10, 4, 0/24. We'll click Create there. Close this, and the last thing that we need to do is we need to associate our route table that allows us to route internet traffic to our public subnet that we just created in our second availability zone. So to do that, I'm going to select Route Tables. I'm going to find our public route table here, and then I'm going to select Subnet Associations. At this point, we need to edit this and associate the new public subnet. So I'll select Edit, find public subnet number 2, click Save, and that's it. All right, we've created 2 new subnets in a separate availability zone. All right, Blaine, we have our highly available network and another availability zone. What else are we doing?
Great. Thanks, Morgan. So just to recap what she's done, she doesn't have to change the VPC because the VPC by definition already is a multi-availability zone structure. All she had to do was add in a new public subnet, which is going to be associated with the same IGW, and she created a new private subnet all in the other availability zone, and this one, like my other private subnet, does not have IGW access. Now, the last thing that Morgan's got to do as far as launching instances, she's going to go ahead and launch a new EC2 instance in this private subnet, and then change my RDS to a multi-AZ RDS that's going to have a standby running in my other availability zone. Go for it.
Okay, so now what we need to do is launch an EC2 instance and another database behind it in our second AZ. I've already done that here. I've already shown you how to launch an EC2 instance, and we had to configure our RDS to have a multi-AZ deployment. Blaine's going to show you that in a later module, so we're good for now. Blaine, let's finish this up.
Perfect. Now, as we could see in the lab, we can connect to this public IP or this public IP, but do you really want your customers to have to choose which EC2 instance they log into? Of course not. That's what load balancers are for. So one more piece to put in here as part of AWS networking is an elastic load balancer, or an ELB. So Morgan's going to launch an ELB and associate that ELB with both of the EC2 instances so that it doesn't matter which one gets the traffic. They're both going to get an even amount of traffic distributed automatically by the Elastic Load Balancer. Let's see what you got.
Okay, so let's go ahead and create our Elastic Load Balancer, or ELB. From the EC2 dashboard, if you look on the left-hand side and scroll down, we're going to scroll to Load Balancers, click Load Balancers, and then create a load balancer. Now we need to select our load balancer type. We don't have to worry about this too much. I'm going to select an application load balancer. From here, we need to give it a name. We'll call this Directory Load Balancer. It's internet facing, and we are going to leave the listeners for port 80 so that people can connect over HTTP to access our website. And now we will select the VPC that we want to launch this ELB into. Ours was the directory VPC. Next, we have to select the availability zones that we will be directing traffic to, which is US West 2A and US West 2B. And then we will select the two public subnets in each of those availability zones. Next, we have to configure the security settings. We can skip through this and configure the security groups, which we are going to click the web security group, which is going to allow us to have that HTTP access over port 80. Next, we'll configure the routing. So we have to give a target group. Our target group for our Elastic Load Balancer is our two web servers. So I'm going to go ahead and name this target group Web Servers. We'll leave the protocol as HTTP and the port 80 and select Next for Register Targets. If you scroll down, we can see our two instances running. So we already have our targets where they're supposed to be. I'll go ahead and select both of those and just click Add to Registered. And now we can see those have moved up to our active registered targets. Next, I'll review. This is everything that we just configured. So we have a load balancer that's internet facing over port 80 for HTTP. We have our targets as our two instances. Let's go ahead and create this Elastic Load Balancer. All right, we've successfully created our Elastic Load Balancer. So now we have an endpoint we can access instead of accessing our two instances' IP addresses directly. So if we click Close here, we should be able to grab the endpoint for this load balancer. That's going to be this DNS name right here. So I'm going to go ahead and click Copy for our DNS name for our Elastic Load Balancer. Now I'm going to open a new tab, and I'm going to paste that DNS name into the address bar, and we can see our application comes up. Now, if you remember when we first introduced this app, we showed you our special info page. So let's browse to that, /info, and now we can see which instance we're running on and which availability zone that instance is running in. We can see here we have this instance ID, and we're running in availability zone US West 2A. So if I refresh the page, we should see the instance ID and the availability zone change because the Elastic Load Balancer is distributing traffic across our web servers. So I'll go ahead and refresh the page, and just like that, you can see the instance ID changed and the availability zone changed. All right, well, that's all we have here. Blaine, let's go ahead and wrap this up.
Well, that's it for basic networking. We're going to add some more things as this course continues, but right now, let's review what we've got. We've got all the pieces you need to run a successful web application. You've got your VPC, the virtual private cloud, that is going to isolate your traffic from anyone else inside AWS. You've got traffic coming in from the public IGW that is going to go through the Elastic Load Balancer and be distributed to either one of the EC2 instances. The instances are going to all talk to the database. The master database has a standby database in the event that something goes wrong. Well, the only thing we haven't talked about is what if you want to communicate to your objects, but you don't want to go to it over the public internet? There's one more type of gateway we can add into your VPC, and that's called a virtual private gateway. And a virtual private gateway, or a VGW, can be created and attached, and this can even be associated with your private subnets, so that if you've got a DBA that is connecting over your own on-premises data center, she can connect through the VGW over a VPN connection and never go through the IGW. And that's it. We've got all the pieces you need. Public access, private access, public EC2, private databases. We're looking pretty good.
Storage is a large part of every enterprise architecture. Building and maintaining your own storage repository is complex, expensive, and time-consuming. Like computing, you don't want to under-provision or over-provision for your storage needs. And as your application grows, so does the amount of data that comes along with it. You want to ensure that you're prepared for this type of change in storage demands. AWS offers a complete range of cloud storage services to support both application requirements as well as archival and compliance requirements. AWS storage options enable customers to store and access their data over the internet in a durable, reliable, and cost-effective manner. You can consume as much or as little storage capacity as needed without having to estimate what your storage needs will be ahead of time. Different storage services are best used for different purposes. Let's think about the corporate address book application we're building. When we look at this page, you can see multiple different types of data. We have both static and dynamic content. There are images for each contact, as well as information about each contact, like their name and location. The images are being served from Amazon S3, and information for each contact, like their name and location, is coming from Amazon Relational Database Service, or Amazon RDS. In addition to this, we also need to store the static content that is the actual HTML document for this site. This is being served from an application server off of EC2. So why are we storing images in S3 but contact data in RDS? S3 is what we call object-level storage, whereas RDS runs on block-level storage. Object-level storage works like this. If you have an image, like we have here, and you want to update that image, you have to update the entire file. So the whole file is going to change. In contrast, databases, like Amazon RDS, run on top of block-level storage. How this works is if we wanted to change the location for a contact, we could just change the corresponding blocks. We do not need to update the entire data file for every single change. For object storage, we use Amazon S3. This provides highly durable and scalable storage for items like images, videos, text files, and more. Storage for databases and EC2 instances use block-level storage, like Amazon Elastic Block Storage, or EBS. For file storage and shared file systems, we offer Amazon Elastic File System, or Amazon EFS. Throughout the next few modules, we're going to talk about each of these services to demonstrate how to store and manage your data with AWS.
Welcome back. Blaine here. We're talking about Elastic Block Storage, or EBS. We've already had a chance to look at the difference between object store and block storage, and EBS provides the most common block storage you will use at AWS. When you launch your EC2 instance, you're going to need some kind of block storage to go with it. As part of the boot volume, or maybe as a separate data volume. And AWS has racks of unused storage that you can provision to sizes as large as you need, up to many terabytes in size. When you launch the EC2 instance, the boot volume can attach directly to your EC2 instance, as well as the data volume. And these volumes live independent of the EC2 instance themselves. In fact, they may already exist before your EC2 instance launches, and when it launches, it simply finds the volume and attaches it the same way you might have an old drive from a laptop that when you get a brand new laptop, you attach and you've got the same old data. This EC2 instance, when it connects to the EBS volumes, now has a direct communication to these volumes. Nobody else can talk directly to them. It's how we maintain secure communications at all times. The EBS volumes have a life cycle independent of EC2. What does this mean? Let's say that this EC2 instance is part of a developer machine that over the weekend nobody's using because your developers go home over the weekend. So during those 48 hours, 72 hours, there's no reason to be paying for EC2 because nobody's using it. All you have to do is simply stop the instance. And when you stop EC2, the EBS volumes survive. They just simply are no longer connected to the EC2 instance. Then Monday morning comes around, your developer starts up an EC2 instance, and a brand new instance is created, and it reattaches those same EBS volumes the same way you would simply shut down your laptop over the weekend and start it again on Monday. But over the weekend, you didn't have to pay for EC2. But there's more we can take advantage of the idea that EBS lives outside of EC2, because what if I want a more powerful machine? Just like I could take your hard drives out of your existing laptop and put it in a stronger laptop, at AWS, you can simply provision a newer, bigger EC2 instance, stop the old EC2 instance, and then just attach the volumes to your brand new EC2. So now I've got the same boot volume, the same applications, the same data, only running newer, bigger, stronger. It's one of the many advantages EBS brings to you as part of AWS.
Hey everyone, Morgan here. We just got done talking about the different storage solutions that Amazon has to offer. We're going to talk about one in particular now, Amazon Simple Storage Service. Amazon Simple Storage Service, or S3, is a highly scalable and durable object storage solution for storing and retrieving any amount of data. S3 is a simple and cost-effective way to store and retrieve your data at any time from anywhere on the web. S3 is a very popular service that is used for scenarios such as basic object storage like images or text files, storage of backups, application file hosting, media hosting, and many other use cases. It can be used to store virtually any type of document or object at a large scale, as S3 has unlimited capacity for your storage needs. Your storage needs are going to grow and change over time, and S3 is built for durability and scalability. S3 offers 99.99% availability with 11 nines of durability. With that level of durability, you can feel confident that S3 is not going to lose your files. We store 3 copies of your data redundantly across AWS facilities within the region that you selected. With this level of durability, S3 is often used as a place to comfortably store backups. This includes backups for components like your databases or your EBS snapshots. To get started with S3, there's a few key concepts that you need to understand. The first concept being that objects are stored in what we call buckets. Buckets are repositories for objects that live in a specific region. Even though S3 is specific to one region, bucket names need to be globally unique across all AWS accounts and must be DNS compliant. The reason for this is that your objects are accessible over HTTP or HTTPS. So when you create a bucket, we provide you with a URL to that bucket. Let's say you create a bucket called My Bucket. We would give you an endpoint. Something like HTTP, your bucket name, which is My Bucket, .s3.amazon.aws.com. Once you have your bucket, you can then start to upload objects into that bucket. Those objects are then also accessible over HTTP or HTTPS. Let's say we have an image. This image is called picture.jpg. Now that we have an object, we can store it in our S3 bucket. Once our object is stored in the bucket, we'll get a URL for that object. You'll notice that the beginning part of the URL is your bucket name, and the end part is going to be your key or your object name. By accessing this link, you can access the object in your bucket. Don't worry too much when we say that your objects are accessible over HTTP. S3 provides secure object storage that you control. By default, when you upload an object into a bucket, it is private. That means if you want to share the URL to the object with another person or application, you would need to configure the permissions on that object to allow access. You can control bucket and object access through access control lists and bucket policies. You can further secure access to S3 by enforcing HTTPS-only connections. You can write, read, and delete objects containing information from 1 byte to 5 terabytes of information per object. Though the size of each object uploaded is limited to 5 terabytes, the overall size limit of the bucket is not limited, which allows for uncapped storage growth. You can store just about anything in S3. It's simple, flexible, cost-effective, and easy to set up. Let's hop into a demo and take a look at how to use S3. Now that we know a little bit about S3, let's go ahead and create a bucket and actually upload an object into that bucket. So we're going to switch to the console view here, and we're logged in. The first thing I'm going to do is navigate to the S3 service dashboard. So I'm going to just click S3, and that brings up the management console for S3. And you can see we already have some buckets in here that our sample application's using. We're just going to ignore those. We're going to make a brand new bucket. To do that, it's really simple. I'm just going to create a bucket, and I'm going to name this bucket Morgan's Public Docs. Next, I'm going to just click Create Bucket, and that bucket will be available for us to upload objects into. Click Create, and as you can see, here it is. It's super simple to create a bucket. At this point, I want to actually upload a document into this bucket and then publicly access that document. So I'm just going to go ahead and click on Morgan's Public Docs, and that brings us into our bucket. Right now our bucket is empty. We just need to upload an object. So I'm going to go ahead and select Upload, and I will browse to my document, which is in Documents. And I'm just going to upload this PDF for AWS Overview. Select Open, and then select Upload. All right, the object has now been uploaded into our bucket. So if I click on this object, I can see the different attributes of this object, like the owner, when it was modified, and you can also see down here, I have a link. This is our publicly accessible link to access that object. So if I click on this and open it in a new tab, you'll notice it says access denied. The reason for that is that all objects are private by default when you upload into S3. So if I want to access this document from the URL, I have to change the permissions on that object first. So let's hop back into the management console and change those permissions. To do that, I'm going to scroll up and select Permissions. From here, I can scroll down and change the public access on this. I'm going to select Everyone and allow read access to everyone. It's giving me a warning here. This object will have public access. This is letting you know that you only want to make documents public that deserve to be public. So I'll go ahead and click Save. Let's go back to our other tab, refresh the page, and I can now see my PDF document. All right, so this is a very simple way to upload and share objects with an S3 bucket. The easiest way to get to know S3 is to get into the console, create a bucket yourself, and have fun with it. We'll catch you in the next video.
Welcome back. Blaine here. We've covered a lot about storage so far. We've talked about block storage with EBS that attaches directly to EC2 instances. And we've talked about object store like S3 or even Glacier that allows us to store single objects in a regional distribution. Sometimes you might have a slightly different block storage need, where you need to have a single store of, let's say, a shared file system that maybe multiple EC2 instances need to connect to. Remember, EBS only attaches to one EC2 at a time. Introducing Elastic File System, or EFS. And the Elastic File System for AWS, EFS, is designed to be a regionally distributed, meaning it doesn't live inside any one subnet, a regionally distributed file store that can automatically attach to multiple EC2 instances simultaneously, many EC2 instances, including to instances in different VPCs. This way, if you need a corporate directory, a corporate file store where everyone connects to the same document store, EFS can be that solution for you. In fact, using EFS file sync, you can even have that directory connect to your on-premises data center, allowing your people at your home network to think they're connecting to home directories when really they're being stored inside EFS on AWS with all the security and regional distribution that comes automatically.
Alan again. In the last module, we looked at networking and storage. We configured a VPC, saw how we could store images and other objects in S3, and used EBS and EFS for block storage. Now in this module, we are going to discuss how to run relational and NoSQL databases on AWS. Blaine will first look at simply running your own database on top of EC2, much like you would on-premise. Then he'll introduce you to the Amazon Relational Database Service, or RDS. RDS is a managed database service where you can pick amongst popular database engines and let AWS manage your database for you. Next, Morgan will demonstrate Amazon DynamoDB. DynamoDB is a managed NoSQL database that, depending upon your application, may be a better solution than a traditional SQL-based database. As in the prior modules, we'll have some resources and quizzes associated with each of these topics to keep you on the right track. Let's get started with Module 3.
Welcome back. Blaine here, and it's time to talk databases. Now, databases are one of the most important parts of any application. There's many ways you can do it on AWS. I want to start a conversation on databases, though, by taking a look at life before AWS. So as we come here to my chart, there's a whole lot of different functions that exist when running your own database. So if I was in an on-premises world, I would be responsible for everything from power and heating and cooling, racking and stacking the servers, maintaining the servers, so on, all the way up to the application itself. One of the great things about AWS is by simply moving your database onto EC2, a large section of what you would have to do on premises, you don't have to worry about on AWS. You don't have to worry about provisioning the hardware as far as racking and stacking it, maintaining the server. Even installing the operating system is taken care of by simply running your system on EC2. What if there was a way to make it even simpler? Introducing the Amazon Relational Database Service, or RDS. At RDS, you still run a relational database of the flavor of your choosing, whether you're talking about a MySQL database, an Oracle database, a Postgres database, or other flavors. But the difference is, instead of taking care of the patching and the installs and installing the database itself, AWS takes care of all of the rest of the heavy lifting that otherwise your DBA would be in charge of. So no longer does she have to worry about managing the high availability or managing backups or taking care of scaling, but all of these pieces now get taken care of because of the relational database service. And the only thing that your DBA needs to worry about is taking care of the application itself. So she still is in charge of getting the right schema, getting charge of the data that's in there, and she is 100% responsible for that. Whether it's encrypted, who has access to it, AWS has no access to the data, But all of the rest of the undifferentiated heavy lifting that goes into databases, AWS takes care of. Is RDS the perfect solution for everyone? You certainly may be in a case where you're using a legacy database. Say you're still running a Sybase shop. You'll still run that on EC2. But as you look for ways to eliminate tasks from your team and let them focus on what they really prepared to do, RDS can certainly get rid of large portions that they don't have to worry about anymore. Welcome back, Blaine here. We're talking about databases. Now, we just covered the differences that you want to consider when choosing between a build your own database strategy and using the Amazon Relational Database Service, or RDS. Again, the big advantage being that we will take care of all those undifferentiated heavy lifting tasks, such as backups or operating system management. I want to show you how easy it is to use RDS in your own account. I'm already logged in here, and all you have to do is go down to the RDS service before you start launching your system. Now, you might already have your own VPC and your own private subnets created. I've already taken care of that in my account as well. When it comes time to launch an instance, all you have to do is say, create a database. And the first question you get asked is, what type of database do you want to launch? Odds are your DBA already knows the answer to this. You might be an Oracle shop, or you might use Microsoft SQL Server, or perhaps just a MySQL or a PostgreSQL database. Whichever flavor it is, we've got the options here, including the Amazon Aurora database, which is a MySQL compatible engine that is designed to work cloud native, meaning it's going to give you more power at less cost, all native inside your VPC. For this demonstration, let's go ahead and launch a MySQL instance. Once we select the instance, we can go ahead and choose Next. And now it's going to ask us a couple questions, whether or not we want to launch a production version of MySQL or just a development version. This is specifically concerned over the idea of a multi-availability zone deployment or a single AZ. If I'm using a MySQL database for a developer, I'm not worried about high availability. In that case, because a multi-AZ strategy costs more, I'd absolutely go with the dev option. But in this case, we're going to be launching a production database. So by choosing the production MySQL, it's going to automatically give us that multi-AZ option. Now that we're here inside the details, we can, of course, choose which database engine version you want, and there's a wide range of different MySQL versions we support. You'll see an option to choose a license model, but in MySQL there is simply the general license that's available. For some of our other flavors, you might have the option to bring your own license or the special licensing agreements that you need, or use the pay-as-you-go option that comes with AWS. Additional options would be how large of a database do you want to start with, and this of course can be changed. If you want to start with a small database and then as demand grows, change it over time, that absolutely is one of the benefits of RDS. Additional options we'll go ahead and take as default, but you can choose as we look at IOPS to know how much communication do you want to provision, what kind of storage do you want. All of these become elements that of course are editable over time, but give you fine granular control over what types of communications are available, as well as what your monthly cost will be. And then, so there's no surprises, it'll tell you right up front exactly what the cost is going to be. How much for the provision IOPS, how much for the database instance and storage. We want no surprises at all as you provision exactly the database you need for your application. Now, we now can choose some settings that are specific to your database. This is going to be your initial login settings, what the master username and password is going to be. Of course, we recommend that you change this once you get logged in, so there's no concerns about anyone else but you having the master password. This database identifier, in my case, is our corporate directory. We give it our master username, as well as our super secret password. By the way, don't ever save the password when it asks you to do that. Now, where do you want to launch it? Now we simply choose which VPC, which subnet group, and we're just going to go ahead and take the defaults out of this. Public accessibility? No, I don't want this public. This is going to be my private database with a front-end instance. As far as anything else, what security groups we want, what individual database options, these all become choices you can do to give you specific elements, and we'll just take the defaults as exist. Encryption. I absolutely want encryption. So in this case, we're going to leave the default to enable encryption, which is going to connect right to our own master key. That's part of our setups. As far as backups go, you set up how often you keep the backups and how long you keep the backups. In my case, I want my backups to retain for not just every 7 days, but I like to keep backups for 2 weeks. So we make that change. We can, of course, say exactly when we want the backups to happen. I'm okay keeping the defaults there as well. Monitoring. Enhanced monitoring is going to give me additional information. We want to go ahead and keep that option available. Performance insights, all these options as default we're going to stick with. And finally, log exports, we want to send them off to. We absolutely can go ahead and select those. On our maintenance contracts for AWS, we want to know if we want to enable minor version upgrades. Do we want to stay on this version so it doesn't automatically upgrade, or go ahead and keep with the current elements? In my case, because my DBA is not tied to a specific DB version, we'll go ahead and take each minor version as it comes. Check with your DBA to decide which option's best for her. And finally, deletion protection. I absolutely want this one checked. I don't want someone accidentally or inadvertently sending a delete command and having it accepted. We've got all our pieces in place. Let's create the database. And now the engine takes over. At this point, we sit back, allow for all the pieces to come into play, and when we're done, AWS will have created the engine for you, in this case a MySQL engine, but for you it'll be whatever database flavor you want in your VPC, whether it's a single AZ or a multi-AZ strategy. It's going to be what you need, and all you have to worry about now is the data itself.
Hi everyone, Morgan here. Different types of databases are built for different purposes. Most of us know and love relational databases to drive our transaction-based processes with well-structured data and complex queries. Relational databases allow for a medium to high amount of throughput and require rigid schemas to be in place. But what if you need massive amounts of throughput, but keep that low latency? Or what if your data model was simple enough and you didn't require the transactional support that relational databases had to offer? You might look into using a NoSQL database instead. Introducing Amazon DynamoDB. DynamoDB is a fully managed, fast, and scalable NoSQL database solution that delivers reliable performance at any scale. So DynamoDB is fully managed. What does that really mean? That means that when you start using DynamoDB, you do not have to manage any of the underlying infrastructure running that database. When you need to start using DynamoDB, you simply create a table, define your throughput needs, and you can start populating it with your data. To compare this with Amazon RDS, with RDS, when you need to use it, you define how much capacity you need in terms of memory and CPU. So you're defining the underlying hardware that we're running your database on. With Dynamo, you simply just tell us how much you need to talk to that table by provisioning your throughput needs. With Amazon DynamoDB, you can start small, specify the throughput you need, and easily scale your capacity requirements in seconds as needed. It automatically partitions data over multiple servers to meet your requested capacity. As your data grows, AWS handles the management of scaling your database. There is no limit on table size, which means you can store any amount of data. DynamoDB synchronously replicates your data across 3 facilities in an AWS region to ensure redundancy and availability. So you're protected from any chaos caused by our lizard friends or any other events that would temporarily disrupt connections to an availability zone. To get a better look at this, let's look at our corporate directory application and how it can use DynamoDB. All right, now that we've learned a little bit about DynamoDB, let's see how our corporate directory application can use it. We're going to hop into the console here. And first, I want to show you guys, I already have the application up and running on an EC2 instance. So I'm going to navigate to the EC2 dashboard, select on the running instances, and we're going to look at our DynamoDB demo app. So I select that, and then I will copy the IP address to that instance, paste it in my address bar, and our application is up and running, and it already has some information populated. This information is being served from DynamoDB. So let's go back into the management console, go to DynamoDB, and look at the table that this is coming from. We'll click Services. We're going to go to DynamoDB, and then we will select Tables. From here, you can see we have an Employees table. This is where our data is coming from. If I select this, and then I select Items, you can see here, this is the information that is already stored in the database. So Morgan Willis, Senior Technical Trainer, located in the US. And then we have an object key for our image, which is being stored in S3. So this is what's already in the application. Let's add one more record and see the table update. So I'm going to hop back to our corporate directory application and select Add. From here, let's go ahead and add our lizard friend. Location, USA, job title, reptile. Our lizard friend is a Mac user, a frequent flyer, and a coffee snob. I'm now going to upload a photo, lizard friend, and save. So now we can see a second record has been added to our application. So if we go back to Dynamo and then we refresh on the items, we can now see we have our lizard friend added into the table. So to show exactly how easy it is to create a DynamoDB table, let's go ahead and create a brand new one. So if we bring this over, let's create a new table. I'm going to click the Create Table button here. So now we need to give our new DynamoDB table a name. Let's make this a students table. So we're going to add a primary key, and the primary key for this table is going to be name. We're going to leave the default settings for this DynamoDB table, but if you wanted to go in and change the provision capacity to be specific to you, you could do that here. We're going to leave the settings as default and click Create. All right, our table is now being created. It is really that simple to get started with DynamoDB. Once our table is created, we can then start populating it with our data. And we're done. The table has now been created. Your applications can point to this table and populate it with data. DynamoDB is fast, simple, and easy to use. For more information on DynamoDB, go to aws.amazon.com/DynamoDB.
It's me, Alan again. To recap, in the last module, we focused on database services on AWS. We looked at running your own database on top of EC2, and we explored Amazon RDS and Amazon DynamoDB. In this module, we will turn our attention to scalability. One of the great things about running your application on AWS is the ability to right-size your resources, adding and expanding to them when demand warrants, and as importantly, reducing capacity as demand declines to reduce cost. To do this, we need to understand what is happening with our application, how it is performing, and how it utilizes resources. Morgan will begin this module with a discussion of our monitoring tool, Amazon CloudWatch. Blaine will then look at load balancing, and both he and Morgan will demonstrate how auto-scaling works. And you guessed it, like in the prior modules, we will have resources and quizzes to keep you on the right track. Let's get started with Module 4.
Modern applications are distributed in nature and are often following a service-oriented or microservices architecture. Components of the system will generate data in the form of metrics, logs, and more, but all of these data sources are distributed throughout your environment. With any system, to support operations, you have to have insight into the current state of infrastructure and applications. You need a way to collect these data points and analyze them to help operate daily and improve your operations over time. Your network will generate data like flow logs. The servers will be generating data such as how much CPU is currently being used. And your database layer will generate data such as number of simultaneous connections. How can you collect this data in one centralized location so you can actively monitor and operate your system? With Amazon CloudWatch, you can monitor your cloud infrastructure intelligently. CloudWatch will collect data from your cloud-based infrastructure in one centralized location. With this data, you can create statistics which drive operational procedures using features such as CloudWatch alarms, which we will talk about in a bit. Let's consider the situation. You get reports from your user base that they're noticing a latency in your services. Since you now have been made aware of an issue, you can start looking at your system to figure out what the cause of the issue is. Upon investigation, you realize that the CPU load is around 95% across all of your server instances. On premises, to fix this, you would page an admin, who then launches another server to help bring the load down across the servers. The problem with this approach, manually responding to a problem, is that your users experience interruption before you can mitigate the disruption to your services. Wouldn't it be nice if we could instead anticipate and mitigate the disruption well before any of our customers are impacted? With Amazon CloudWatch, you can configure metrics and alarms to do just that. CloudWatch collects data points over time and provides you with statistics about your infrastructure, so you can then create alarms and trigger automated events based on those statistics. Consider our previous example. Instead of waiting until hearing about latency from users, instead, you can create an alarm that says, if a group of EC2 instances has CPU over 60% for more than 5 minutes, trigger an auto-scaling policy, automatically launch a new server into the pool, and alert an admin. The visibility into the CPU across EC2 instances is what allows you to anticipate that your users will soon be experiencing latency if you don't act. CloudWatch alarms can be configured for more than just CPU utilization. You can choose from hundreds of different metrics, or create your own custom metrics for alarms that matter to you. In addition to alarms, CloudWatch also allows you to visualize the statistics about your environment through dashboards. You can use out-of-the-box dashboards to view built-in or custom metrics, and you can build your own custom dashboards or partner with a wide range of consultants through the Amazon Partner Network. When building custom metrics, consider the data being generated in your log files. Systems generate different types of log files that have a wealth of information about system performance and error rates. CloudWatch Logs is a place where you can send your log files for viewing in the console and to stream to other services like Lambda or Amazon Elasticsearch for analytics. CloudWatch is integrated with over 70 AWS services. You can use CloudWatch to set alarms, visualize logs and metrics side by side, take automated actions, troubleshoot operational issues, and discover insights to optimize your applications. Getting started with CloudWatch is easy, and there's no upfront commitment or minimum fee. For more information, visit aws.amazon.com/cloudwatch.
Welcome back. Blaine here. We want to talk about load balancing. Load balancing is not a new concept. As we look at a complex application, you might have a variety of different application servers that all need to take traffic balanced from the outside. There has been many tools that have existed for many years, HA proxy servers or more complex vendors like F5. At AWS, we believe in eliminating undifferentiated heavy lifting. In other words, everyone needs load balancing, so we provide it as a service. Introducing Amazon Elastic Load Balancer, or ELB. And the idea behind Elastic Load Balancing is it is a regional service that launches inside your VPC. When you launch it, you've got a number of flavors you can choose from based on your application needs, whether you just want pure network load balancing or sophisticated application level load balancing that can send to different parts of your application based on what it sees. But the fundamentals are the same. Traffic comes into the load balancer from the outside. And it doesn't matter the volume. You don't have to tell us in advance if this is a small amount of traffic or a large amount of traffic, because the point of being elastic is it knows automatically how to scale. And being a regional construct, as opposed to just being a server, means you don't have to worry about maintaining individual nodes or maintaining any kind of high availability. It's automatically highly available. The traffic comes in, and the Elastic Load Balancer knows all of the different instances that are signed up to take traffic. And in fact, if you have auto-scaling set up and more instances come online, then the Elastic Load Balancer can absolutely send traffic to those as well. The advantage then is automatic traffic distribution to the instances, and it doesn't even have to come from external traffic. ELB can also be used internally to help decouple instances. For example, you might have a front-end web server fleet that then wants to communicate to an application tier. Instead of having each front-end web server know each application tier, you can simply have your Elastic Load Balancer in between take care of handling all those relationships. When you need load balancing, ELB does it as a service to save you time and effort, but still get the results you need.
Hi everyone, welcome back. Morgan here. Let's recap what we've built out so far. Previously, we built our application and launched it on 2 separate EC2 instances. Those EC2 instances lived in 2 separate availability zones and 2 public subnets. We then had our private subnets with our database instances in them. We also created an Elastic Load Balancer. Our Elastic Load Balancer distributed traffic across our EC2 instances. Let's imagine a scenario where our corporate directory application starts to get really popular. As more people visit our application, the demand on our 2 web servers is going to go up. At some point, our 2 instances aren't going to be able to handle that demand, and we're going to need more EC2 instances. Instead of launching these instances manually, we want to do it automatically. So we're going to use what's called auto-scaling. Auto-scaling is what allows us to provision more capacity on demand depending on different thresholds that we set, and we can set those in CloudWatch. You know what? To get a better idea of this, hey Blaine, can you draw this out for us?
You bet, Morgan. Let me go ahead and explain a little bit about, wait a minute. We're doing a super lab again, aren't we? Yeah, we need our jackets. Hold on.
You know, if you insist on super lab, that's fine.
Super lab time, here we come. Wait, this isn't just super lab. It's time for super duper lab. Here we go. Ready? Let's do this. We are looking at an EC2 distributed system where you've got multiple subnets across multiple availability zones. EC2 instances that are created inside an auto-scaling group, meaning they're identical. They can launch as needed by the auto-scaling engine, all connected through the Elastic Load Balancer. So traffic coming in from the outside can easily come down to either EC2 instance, but there's going to be more because we're going to take those EC2 instances and we're going to stress them out. We're going to run an application that's going to make these think they're overloaded, and when they do, they're going to be sending metrics over to CloudWatch. CloudWatch is watching for whenever their CPU crosses a certain line, and when it does, it's going to tell the auto-scaling engine that we need more EC2 instances launched in each availability zone. It's going to happen automatically without any humans doing the work. All right, Morgan, show them how it's done.
Okay, so to get this built out, we have to create an auto-scaling group and a launch configuration. This is going to define where we're launching our new instances and what to launch. So let's look at the console and see how to really build this out. First, what we're going to do is from the EC2 dashboard, we can scroll down and we can select auto-scaling groups. I'm already on that page, so we're just going to go ahead and create auto-scaling group. From here, I'm going to select launch configuration, and I'm going to create a new launch configuration and click next step. The first thing to do is to define what AMI we're going to use. So again, our launch configuration is what are we going to launch. So we have web servers out there that are already receiving traffic. We want to create mirror images of those web servers so that way, whenever we scale out, We just have more instances with the exact same configuration. So that's our launch configuration. Let's go back to the console. So as we did when we launched our EC2, we're going to select the Amazon Linux AMI, and we're going to keep our T2 micro. From here, we will configure details. We'll give our launch configuration a name. We'll call this web server, and we will give it the role instance role. This is the same role that we gave to our EC2 instance when we launched that previously. So now we have to expand the advanced details, and we paste our user data. Our user data, again, is what goes out and grabs the source code and unzips it so that our application is running on the EC2 instance. We'll click Next for Add Storage. We'll just hop through this. We don't have to worry about that. We'll configure our security group by selecting an existing security group, and we will select the web security group, which enables HTTP traffic. Next, we will review. We'll go ahead and get past this warning by just clicking Continue. And here we can see our launch configuration. We have our AMI, our instance type, and we have our security group for our web traffic. Again, this is all the same settings for our existing EC2 instances. Here I'll create the launch configuration. I will acknowledge the key pair and click Create Launch Configuration. Now that we've configured our launch configuration, which again is going to define what we're launching and the configurations for those instances, we now have to define an auto-scaling group, or where we are going to launch those instances and when to launch them as well. So we can see on the screen here, our launch configuration is already populated to web server. So we're going to go ahead and give this auto-scaling group a name. We're going to call it web servers. And our group size is going to start with 2 instances. This is so that we can have instances across availability zones, 1 in each to start at a minimum. Next, I'll change the VPC to be our directory VPC. And then for the subnets, I'm going to select both of our public subnets that we created. If we scroll down to the advanced details section, we also have to select for the load balancing to receive traffic from 1 or more load balancers. This is because we've created an ELB in our VPC. We're going to call this target group web servers. Next, we can configure the scaling policies. So for scaling policies, what we're talking about here is you can set up a scaling policy with CloudWatch that whenever your instance capacity reaches a certain limit or any other metric that you would like, you can add more instances to the pool, which would deploy more EC2 instances into your auto-scaling group. So we can do that right here. So what we want to do is use scaling policies to adjust the capacity of this group. We want to scale between 2 and 4 instances. 2 is the min and 4 is the max. We'll name this scale up, and our metric type is going to be the average CPU utilization. Our target value is going to be 60%, and instances are going to need 300 seconds to warm up before scaling. We can go ahead and click Next now to configure our notifications. You can configure notifications when scaling events happen. This is optional. So for now, we're just going to skip past it. We can configure tags as well, but we're going to skip past that for now too. Next, we will review. And here we can see we have our auto-scaling group defined. You'll notice that we skipped through some of the configurations. That's because these are optional. By default, we can keep it simple and go ahead and just create our auto-scaling group. So I'll click Create Auto-Scaling Group. All right, our auto-scaling group has been successfully created. So now all that's left to test is we need to stress our application and make sure that our application does scale. So to do that, I'm going to open up a new tab. I'm going to paste the endpoint for our Elastic Load Balancer. Here's our application. I'm going to go back to that info page, and you'll notice down here that we built in a stress CPU feature. This is going to mimic the load coming onto our servers, and then we can watch our servers scale with that auto-scaling policy. So as the CPU utilization goes up, our auto-scaling policy will be triggered, and our server groups will grow in size. So I'm going to go ahead and select 10 minutes for our stressed CPU. All right, some time has passed, we've stressed our application, and if we take a look at CloudWatch, we can see what happened. So let's click on CloudWatch, and if you look here, we can see our alarm summary. So we stressed our system, and I'm going to click on this graph to show you guys what happened. So we stressed our system, and you can see here the spike in CPU. So we went over 60% CPU utilization across instances. That was our threshold to launch new instances into the pool. So we launched 2 new instances into our auto-scaling group, and then you can see the load started to come down. Because we've launched more instances into our auto-scaling group, there were more hosts to accept traffic from our elastic load balancer, and the average CPU utilization then went down across our servers. All right, so let's exit this and go look at the EC2 instances that were launched into the auto-scaling group. So I'm going to close this. I'm going to go to the EC2 dashboard. And from here, I'm going to scroll down to target groups. I'm going to select web servers, which was our auto-scaling group. I'm going to select targets. And we can now see that we have 4 healthy targets in our auto-scaling group. All right. So now we have an environment with an auto-scaling policy and a launch configuration. We've set up an alarm in CloudWatch that whenever our CPU utilization goes over 60%, we're going to launch more instances into that group. Okay, Blaine, can you draw some things out for us to help us visualize this?
Great. So let me just recap exactly what you just saw. You had your EC2 instances, and again, they're part of the auto-scaling group. They're identical. They're launched as part of the launch configuration. As they were put under stress, they all reported down to the CloudWatch engine saying their CPUs were overloaded. CloudWatch went into an alarm state and told the auto-scaling engine, give me more EC2 instances. As they each came online, they all reported back to the elastic load balancer. They got traffic, ending up giving us all the scalability we need. Now, if we wait around long enough, what we would see is as the CPU load dropped off, then one by one, they would each get terminated because we no longer need them, bringing our state all the way back down to the basic 2 we need, the minimum number for this particular group. All of that done without any human intervention. I love the automation. Back to you, Morgan.
Thanks, Blaine. All right, so we've used CloudWatch to monitor our EC2 instances. When our instances went over that threshold, we had an alarm in CloudWatch that triggered our auto-scaling policy. For more information on CloudWatch, visit aws.amazon.com.
Yes, Alan again. Welcome to the last module of Going Cloud Native on AWS. You're almost done. After the last module, where we discussed monitoring and scaling, we now have a robust application that is almost ready to be rolled out. But before we do that, we have a couple of important topics to discuss. Security is of utmost importance here at AWS. Blaine will review our shared security model. When I was a technical trainer, one of the first questions I was asked when introducing AWS to customers was, how much is this going to cost? Morgan will look at some of the tools AWS offers to help manage and understand costs. Finally, I will have a brief preview of some future offerings in this AWS Fundamentals series on Coursera. And once again, like in prior modules, we'll have some resources associated with each of these topics, as well as quizzes, and, in this case, a final exam to wrap up. Let's get started with Module 5.
Welcome back. Blaine here. We want to talk about security. Anytime you talk about security at AWS, you need to talk about the shared responsibility model. The idea is, at AWS, we talk about security as a partnership. There are things AWS is responsible for and things you are responsible to do in order to keep your application safe and secure in the cloud. An easy way to understand that is to take a look at your application not as a single object, but as a collection of pieces that together make up the parts of your app. We start at the beginning, right at the bottom with the physical data centers. This is the concrete and iron, the barbed wire fence and the security guards. Someone's got to maintain control over ingress and egress over that physical facility, and that's 100% AWS. Even when it comes to protecting against our fine lizard friends, we take care of that, and you don't have to worry about that part. On top of the physical infrastructure, we have the AWS network. We run our hypervisors for EC2 and other applications, and all of these pieces we take care of. Now, do we disclose information under NDA or other elements to help you understand what's happening? Where we need to. But we take care of this, and we provide the security elements to you and your auditors where compliance is needed. When you're running EC2 on AWS and you launch EC2 and you choose an AMI with an operating system, that guest operating system is 100% in your control. And this becomes the dividing line. AWS takes care of everything below the line, and with EC2, everything from the operating system, whatever applications you run on EC2, and especially all of your user data is controlled by you. This means it's your responsibility to think about things like, do you want encryption? AWS offers a wide range of encryption tools, whether it's simply a bring your own encryption to automatic server-side encryption on S3 and EBS. Or perhaps you'd like a more robust managed keys using AWS Cloud HSM or KMS, the key management service that allows you to retain high-level controls even when you've got security like a FIPS 140-2 compliance. We can take care of that and give you the validations needed so you can prove your certifications. Every service at AWS has a dividing line. Below the line, we are responsible for security. And above the line, it's your job to make sure you protect your data, you take your user management, that your application is free from whatever vulnerabilities might exist. But in some cases, you don't have to worry about the application. Think about RDS, the relational database service we talked about before. In that case, there's still an application. There's still an Oracle application or a Postgres application or even the new Amazon Aurora application. But in those cases, AWS is responsible for installing and maintaining and keeping all the patches up to date. And you or your DBA doesn't have to worry about the operating system or the application. And in fact, there's a different dividing line for RDS. You, though, still maintain 100% control over the data itself, over the schema, over user access. Am I encrypted or not? Who has access to read it? Just because you're running on AWS's servers does not give us any visibility at all into your data. And if you don't trust that, don't worry about trust. That's what encryption's all about. With enough encryption, you don't have to worry about who else is running inside the cloud or anywhere else in the world. With the shared responsibility model and understanding where the line exists between the different services, this is going to give you the information you need to know the parts that you need to be responsible for to stay secure in the cloud.
Let's talk about cost. When you use AWS, you spin up resources only when you need them, and you pay only for what you use. Instead of having a fixed cost, like you would have in a traditional on-premises environment, you instead incur a variable cost. This is fundamentally different than the way costs were managed on-prem, and therefore has shifted the way that costs are understood, managed, and optimized. To optimize costs, you want to establish best practices for cost management and use tools to monitor and analyze costs over time. AWS offers multiple cost management tools through the AWS Management Console. The AWS Cost Explorer is a service that helps you easily visualize and understand costs and usage. AWS Cost Explorer also allows you to create reports. There are default reports built in, or you can create your own more granular reports to analyze cost drivers. Another tool AWS offers is AWS Budgets. AWS Budgets allows you to create alerts when your costs or usage exceeds a threshold over a specific time period. You define the time period, whether it be a week, month, or year, and you also define your thresholds. When you exceed the threshold, a notification can be sent out, so you can begin to look into where you can start to reduce costs. One tool that can help you identify places for cost savings is AWS Trusted Advisor. AWS Trusted Advisor not only helps you reduce cost, but it also can help you increase performance, increase security, and optimize your AWS environment. Trusted Advisor is a powerful tool to help you identify areas of improvement in your account. Let's take a look at the console and see what kinds of things Trusted Advisor can help you with. All right, so we're at the console here. We're already logged in, and I'm going to go ahead and navigate to Trusted Advisor. All right, so we've arrived at our Trusted Advisor dashboard. You can see we have a few different categories of things that Trusted Advisor can help you with. We have cost optimization, performance, security, fault tolerance, and your service limits. Right off the bat, I can see that this particular account can save $26.39 of potential monthly savings. So if I click on the cost optimization category, I can get some more details. Scrolling down, I can see that I have some underutilized EC2 instances. What this means is that the daily CPU utilization was 10% or less. So if I open this some more, it will give me more details. It gives me a recommended action, which would be consider terminating or stopping those instances that have low utilization, or you can scale the number of instances down or scale one particular instance size down as well to save money. If we keep scrolling down, we can see that we have 2 specific instances that are being underutilized, and we can see the estimated monthly savings for each instance. Similarly, if we continue to scroll down, we have another check against EBS volumes, and we have 2 underutilized EBS volumes here, and again, it will show us the projected monthly savings if we unattach those volumes. All right, let's go back to the dashboard, and let's select another one. I'm going to jump into fault tolerance. So now we're at the fault tolerance category, and you can see here that we have 2 warnings for action recommended for fault tolerance checks. What this is trying to tell us, if we expand, is that we have some EBS snapshots where the age of those snapshots is more than 30 days old, or the EBS volume doesn't have a snapshot at all. So that's not very fault tolerant. We want to make sure that we're taking regular backups and snapshots of our EBS volumes. The next thing that we have here is Amazon EC2 availability zone balance. This is letting us know that we don't have an even spread across availability zones for our EC2 instances. And we remember talking about fault tolerance and high availability. You want to use 2 availability zones for your EC2 instances. There's many tools that can help you manage your costs in the cloud. To get started, go to Trusted Advisor in your account and see exactly how you can start optimizing your environment.
Congratulations on completing, and thank you for taking this course, AWS Fundamentals, Going Cloud Native. We covered a lot of territory. We started with an introduction to AWS services and then explored AWS regions and infrastructure. Next, we focused on some fundamental AWS services in the areas of compute, networking, storage, databases, monitoring, and scaling. We finished up with an overview of security and cost management. So you may be asking, where do I go from here? Throughout the course, we have provided links to AWS documentation and resources. The best way to further your understanding of these services is to get hands-on experience. Please take advantage of the AWS free tier and jump in. This is the first class in an ongoing series of classes we are creating on Coursera. This class utilized server-based solutions, and our next class will focus on serverless solutions. Specifically, we will look at services such as AWS Lambda to create on-demand compute services without having to manage and maintain servers. In later classes, we will dive deeper into some of the topics we discussed in this class, such as security and database services. Please stay tuned for details. On behalf of Blaine, Morgan, and our lizard friend, thank you for taking our class. We hope you've learned some new things and enjoyed our time together. Now, little one, let's go find our buddies.